is that, and Mark may talk about this, the operations group, after the start of the year, has decided that 20% of their incentive compensation for the entire operations group is going to be based on their performance against the Service by Design targets. And remember, those targets are to some extent set by what we tell them that they need to be for our customers. Joe Galassi wrote me a note the other day and said, I think marketing ought to have part of your incentive set on how well we meet Service by Design targets, because you are the ones who set those targets for us. And I thought that was a very good idea. I declined just because of the complexity of making another change mid-year in our incentive plan, but had it been earlier, I would have considered that. So we've got a big stake in what Mark is doing, and he has got a tough job, and ultimately he's working for us, and about, I don't know, thousands of people in operations have their incentive compensation riding on their performance against the system Mark is setting up. So this is of high interest to me, and I think it should be to all of us. Mark?
I'm really happy to be here for two main reasons. First, it's among friends, and I've really appreciated the time that I had working in the marketing department. Made a lot of great friends for life as far as I'm concerned. Also, I'm happy to be here because I'm going to talk about something that I think is really exciting, something that's a trend-setting opportunity for not just Burlington Northern but the industry, and I want to share that with you. I wanted to start out by laying out the mission statement of Burlington Northern Railroad, because what we are doing in service design relates directly to this. If you take a look at the first sentence of that mission statement, it says that our goal is to design and consistently deliver transportation and information services that exceed our customers' expectations. If you go back into our history, I think you'd find that we have not really been that successful at doing that. We have not designed consistency into our services. We have not delivered consistency with our services. And that's why about 2 years ago, Burlington Northern started the service design effort. If you remember right, it was started by Hunter Harrison. And I'd like to take you through a little bit of an update on this service design process. First off, I wanted to show you a little bit of information about how the service plans, the operating plans, are really developed. I believe it's really important that you understand the foundation that we're working from in this service design process, because hopefully you are selling service and you need to know what's going into this service. Second, I'd like to brief you on how we performed in 1989 against our service standards and explain a major change in emphasis that was kicked off at the beginning of this year in how we measure our performance, what are our targets, and then explain how we are performing in 1990 against those targets. That's a third thing I'll talk about. And then fourth, talk about where do we go from here, because we've started a pretty intense effort here, but we have a long way to go to get to where we need to be. I'd like to talk about that also. When the service design group was put together, one of the first things that they did was to take a look at the causes for our service failures. And I thought you'd be interested in this because this was done about 1.5 years ago. And it shows that in the merchandise businesses, that is food and consumer, industrial products, forest products, automotive, primarily those areas, the causes for service failure came 31% from terminal handling, that is at the origin or destination terminal. Burlington Northern just frankly messed up. We didn't handle the car as we should. The second major area was in intermediate terminals. That would be, for example, a shipment going from, say, Chicago to Seattle, and it gets humped at an intermediate station like Northtown. We just didn't comply with our standards. 30% of the time, our failures were caused by that. 18% were failures caused by problems with connecting carriers. That is, somehow or other, either due to our fault or the connecting carrier's fault, we had a mess up at the interchange point. The fourth main reason was train performance. 12% of our service failures were caused by train performance. What's ironic about this is that historically, that's where the bulk of the emphasis has been placed in operations on improving service. You get the trains going over the road according to schedule and everything will be wonderful. Well, this is showing you that only 12% of our problems actually were caused by train performance. Now, I have to throw in a caveat there that a lot of your terminal failures happen because your trains aren't hitting the proper windows and terminals. But there are other problems associated with those things too. Train performance in and of itself is 12% of our failure causes. Other causes were like bad orders, for example. That was 9% of the total failures. Again, the historical emphasis has been on train performance. The emphasis with service design has been on car performance. It's this understanding of the causes of the service failures that has driven the whole service design process. And this process is really grounded, at the heart of it, is in the service and operating plan. And I really believe that you need to understand this process to effectively guide, because it's important that marketing guides this effort, and sell the service that we're providing to customers. What we are doing in service design is establishing car movement standards. Trains are a big part of that, but the prime focus is on car standards. And we believe that that is going to give you something much beyond price to sell with. Now, how does this process work? In other words, what's behind the numbers that you'd get if you do an inquiry into the service management system to find out the standard for a shipment? Well, first, we've divided the system, Burlington Northern system, into about 175 service areas. If you take a look at this chart, it shows our service areas are in the Alabama, Tennessee, Mississippi, and southeastern Arkansas area. And you can see that we've identified on here a couple of what we call service nodes: Jonesboro, Blytheville, Harvard, Memphis, Amory, Birmingham. The reason that the system was broken down into these service areas is because if you took every origin-destination pair possibility across Burlington Northern, including the various event possibilities within terminals and such, you'd have well over 10 million possible origin-destination pairs. It's very, very difficult to try to get a handle on that many opportunities. So we tried to break down the system into some logical service areas to break down the complexity and make it easier for you to deal with. Now, customers in every one of these service areas, for example, say in the lower right-hand corner there you see 002AL and 001AL. Those are service areas served by the Birmingham area. Every customer within that service area gets like service, the same level of service. Within the terminal areas that I identified on that previous chart, and I showed you 6 terminal areas out of these 175 major service nodes that we've created, you have further detail. In the Memphis area, for example, you can see that we've broken that terminal complex down into 6 industrial zones. Customers within each of these industrial zones also get like service, similar to like service given to customers served by locals outside of the major terminals, which were identified by those other service areas I talked about before. Now, within these industrial zones, a customer may get more than 1 switch a day. You could have 3 switches a day. The service standards are set up to identify the cutoff times that we have worked out with the customers to tender their shipments to us or make them available for us to pick up. And then everything else is driven based on that initial cutoff time. Now, a zone could be one customer. An example would be Coors in Denver. They are such a large customer that they are one whole zone. Now, all this information that I just talked about, the industrial zones within a major terminal complex, the minor area zones that I talked about in the chart before that, come together in what we call a terminal table. Now, this gives you an example of a very simple terminal table that has a combination of all the various activities that you can see. This is for Sumas, Washington. It contains the service standards within a service node area. And again, remember I said there are 175 or so of these across the system right now. Now, what you have here are what we call from events and to events. You have standards established for from interchange. For example, the top line there is from the BC Hydro Railroad, saying that we expect to receive from them an interchange cars by 1600 hours. That if we do receive it at 1600 hours, we expect it will take us 2 hours to process those cars in Sumas, and they will be available for the next outbound activity at 1800 hours. If you look to the far right-hand side of that chart, you can see that we expect that to happen 7 days a week. There you see the specification of the frequency of that service. Farther down the line, you can see from industry. We see a line that shows from industry from 01 and then 4 zeros to 6 nines. Those are SPINS numbers, specific industry identification numbers. And Sumas is a relatively small terminal, so there's only one group of SPINS numbers to satisfy the whole terminal needs. And what that says is that if customers within the Sumas terminal release a car by 1600 hours, we will have that car available for the next outbound move by 1800 hours. And that we serve the industries, we have industry switch jobs in Sumas, Monday through Saturday. We do not have industry switching on Sunday. Again, this has been worked out with the customers as far as we know. And I'm going to be hitting you for some help in here later on. Next area, from train 644. There's only one train that serves Sumas inbound and outbound. 644 inbound, 643 outbound. And this says that for 644, if we start building that train at 2000 hours, and we receive that train within the yard. The standard is 2000 hours. That's when the train's supposed to arrive. We take 12 hours to classify those cars, have them available to switch to industries or to connections by 8 a.m. Now, I'd skipped over one line. I apologize for that. The MAS line stands for minor area stations. The first MAS line, which shows station numbers 66054 through 66083, shows industries that are located on the Sumas main line. And it says that we have standards here for when we would switch those industries, what time the customers would release cars from those stations, and then how long it would take us to process those cars. This, again, the terminal table is the guts of standards within minor areas and within major terminals. Now, how would you develop a standard for a movement? Let's say we want to traverse across the system. Let's pick out a hypothetical. Say we want to go from Sumas, from say a lumber shipper within the Sumas yard, and that shipper is going to go to some point on the CSX railroad and they want to have it go over the Chicago Gateway. Well, what would we see? We would see terminal table activities where this car would change trains at 5 different service nodes. Starting in Sumas, where we begin the transportation, it goes through Everett. There we change from 643 to train 696. At Pasco, we go from train 696 to train 100. At Northtown, we go from train 100 to train 142. And at Cicero, we go from train 142 to an interchange cut to CSX. Now here you see some of the activities from these 175 terminal tables coming to play. Now this shipment would go through many more terminal tables than the ones I've specified here. I've only picked the ones where you'd see a change in train ID. You notice that we've gone through 4 trains to get this shipment across the system. Let's take a look at how these service nodes, the terminal tables, are linked, because we have standards for train shipments too. Recall train 696 that we said would carry the shipment from Everett to Pasco? Well, here you see a copy of what we call a train brief. The train brief lays out our standards outside of the terminal. That is, how is this shipment going to be handled to link the various service nodes? On this train brief, you can see we specify the frequency of the train. Train 696 runs daily. It handles merchandise freight, which is specified in the upper right-hand corner. We have train and locomotive guidelines specified in this standard. That is the minimum horsepower per trailing ton that's required to power this train. We have information there on the locomotive cutoff time. That is, the locomotive must be available, or locomotives must be available at Everett by 9:01 a.m. in order to be available for this train. Now that's a very important number for the people in diesel control, because the locomotive distribution system has that in order to specify when locomotives must be available to make sure we keep our train commitments. You can see that on the far right-hand side of this train and locomotive guidelines section, we show a maximum footage that it's allowed on this train. That's for meet pass planning. We want to make sure that the train isn't so long that we can't make the appropriate meets along the route. Many trains have maximum tonnage guidelines, especially if they're going to go over mountain territory. Farther down, you can see the actual schedule for the train. The train is supposed to depart Everett at 12:01 p.m. on day 0, and you can see the time it goes through the intermediate points. Finally, arrives Pasco at 7 a.m. day 1. The bottom part of this standard for train service shows the activities that this train does on its route. For example, at Everett, it picks up Pasco and beyond freight, and we also show the grouping guidelines. That is, how is this train to be blocked so that we make sure that it's set up properly for downline terminals so they can process this train, the cars on that train, in the most effective way. So this gives you an idea of the complexity that this business really has inherent in it, and all the planning that has to go into making our operation